Great. So our next speaker is Arnon Dag. He's coming to us from Israel. So he's been very gracious. He's 9 hours ahead of us. So Arnon is a senior researcher at the Department of Fruit Tree Sciences at the Agricultural Research Organization in Israel. That's roughly equivalent to the USDA. He obtained his master's degree from Tel Aviv University and his PhD from the Hebrew University of Jerusalem's Faculty of Agriculture in Rehovot. He worked for 10 years in the Extension Service before joining the ARO as a researcher. His main research interest is pomology under arid conditions, and especially olive, avocado, jojoba, table grapes, and pomegranates. And he was the scientific director of R&D for South in Israel for 6 years. His research activity has resulted in more than 130 papers in peer-reviewed journals and 100 papers in local journals. And I've known Arnon probably, 30 years we've known each other?
Something like that, yeah.
Something like that. He's known Ben. He's visited here in California, spent sabbatical. And he's worked on everything, avocado flowering, all kinds of things. But he's been a key lead person on this whole topic of canopy cooling. So with that, he's going to talk to us about canopy cooling and the results they have in Israel. Arnon.
Thank you, Mary Lou. Thank you for inviting me and giving me the opportunity to show our results. So some background about heat waves, what we have in Israel, and probably it's relevant also for your condition. Spring heat wave caused substantial fruitlet abscission in avocado in Israel. In Hass, half of the interannual variance in yield was explained by spring heat stress. Therefore, the objective of the study that I will show you is to evaluate the use of irrigation system for overhead canopy cooling in avocado orchard. Something like 30 years ago, there was a publication of researcher, his name was Lomas, and he was a meteorologist, and he looked for the correlation between heat to productivity in avocado in Israel, and you can see he evaluated 4 different cultivars, and he found out that Hass is extremely sensitive to heat wave, and he found very strong negative correlation between heat stress index to the productivity of Hass. When he spoke about heat stress index, he referred to the daily maximum temperature, 33 degrees Celsius or greater, the duration of such high temperature in days, and the timing of such heat spell in relation to flowering and early fruit. So this is the most sensitive stage, the end of the flowering and the young fruitlet. They are the most sensitive to heat waves. Therefore, if the heat wave appear during this early development stages, then the damage will be the highest. So what is actually happening if we have hot and dry wind in Israel? We have certain type of those heat event in California. You probably have other type. I think part of it is called Santa Ana winds. So it's many times it's combination of heat, wind, low humidity, and strong radiation. All of them cause the increase of VPD, vapor deficit, and it's cause very strong stress for the tree. High transpiration lead to water stress, and stomatal closure accelerate the heat stress of the tree because the tree cannot cool itself. And both the water stress and the heat stress cause fruitlet abscission, and then we have yield loss. So we see very strong relation between the meteorological condition to the functioning of the tree and its productivity. We can see different phenomena in the avocado orchard at those early stages of fruit development. Following heat wave, we can see fruitlet burning, we can see branch burning, we can see inflorescences drying, and sometimes like a carpet of fruitlet on the ground following those heat waves. In Israel, and as I understood also here, also in your case in California, the frequency of those heat waves increase. You can see here a graph that show us the number of days with maximal temperature above 40 degrees Celsius. And we can see that along the year we are facing more and more those extreme events. There are different methods to cope with heat stress if we look in the literature, to use heat-tolerant rootstock, to use net shading, to use particle film application like kaolin, manipulation of fertilization, to irrigate more. And I will focus on evaporative cooling. Ben already mentioned it, and I will try to enlarge the picture. The rationale behind this method is that orchards already have pressurized water system for irrigation and fertigation. So we may use this water irrigation system for additional purpose to cool the canopy of the tree during severe heat wave. So we use this system to provide water, to provide fertilizer, and now we can use it also to cool our orchard during heat waves. We try to calculate along our studies the amount of water required for this purpose, and it's around 5% of the total amount of water used for irrigation was used for the cooling. So it's not substantial amount, but when we apply it at the right time, we have very good impact. So the idea of evaporative cooling is reduction in temperature resulting from the evaporation of liquid, which removes the latent heat from the surface from which evaporation takes place. We are familiar with from different instruments like desert cooler, like other instruments that use this evaporation to cool water or to cool some elements. The experiment that I will show you one in 3 different locations. You can see in the right side, you can see the map of Israel, and in red color, you can see the distribution of avocado orchard. Most of them are located along the seashore, and part of them in the Western Galilee and in the north to the Sea of Galilee. We concentrated in avocado orchards that planted in the southern part of Israel, in area that is semi-desert area, which facing higher temperatures than in the northern part of Israel. And we had 3 sites. The one in the western side is called Saad, Kibbutz Saad, then Gevim, and then Ruchama. The first 2 sites were evaluated at the beginning, and then we added the 3rd site in Ruchama. In Saad and Ruchama, we use fresh water for the cooling, and in Gevim, we use reclaimed wastewater. I will show you the quality of the water in a minute. So in general, when we are going inland and we are going away from the sea, the severity of those heat waves is increasing because the humidity during the heat wave is lower. The type of water we use in Gevim, when we use the reclaimed wastewater, was 183 milligram per liter of chlorine and 125 milligram per liter of sodium, and the EC was 1.1. It's considered to be reclaimed wastewater in high quality in Israel, but still the salt load is much higher than fresh water. You can see the chlorine and sodium in the fresh water. The fresh water source in Israel in those areas is a desalinization plant near the sea. So we use the fresh water in Saad and Ruchama that I will show later. So we have 2 types of water sources. One is higher level of salt, and the other one with lower, and I will show you how it impacts the tree later on. Along this experiment, we ask ourselves what the proportion of water that actually evaporate from the tree and what run off to the ground. So we found out that around 40% of the water is runoff. It's reached the ground, and add some water to the tree. And around 60% is evaporate. And this is approximately the amount of water. We just installed some big pan below the tree and collected the water after operating the system, and then we could evaluate these numbers. So at the beginning, we started with 2 orchards in Sad in Gevim. As I mentioned, in Sad, fresh water, and Gevim, reclaimed wastewater. The threshold to operate the system at the beginning was 33 degrees Celsius and below 40% relative humidity. And then we understood that this threshold is a little bit too low, and we can take it a little bit more to the extreme, and then we adjust the threshold later on to 33 degrees Celsius, which is 95 degree Fahrenheit, and relative humidity below 30. So most of the result I will show, we use this threshold for autonomous operation of this system. When we reach those threshold of temperature and humidity, then the system starts to operate. At the beginning, we tested different type of sprinklers and sprayers in Gevim and in Sad. In the year 2020, we faced very severe heat wave of 6 consecutive days with temperature above 40 degrees or around 40 degrees Celsius, and humidity was reached below 10%. And you can see here the gray bar showing us the timing of operation of the system. So this was a very extreme spring, the extremist situation, and we had 6 days one by the other in which the system was operated. And I will show at the beginning, I will show the result of this event, how the system affected the tree performance. First of all, let's look about temperature. So we use here remote sensing using drones with thermal imaging, and we evaluated the temperature. You can see the dark colored squares are representing the area in which we tested the different sprinklers and sprayers, and we can see that the temperature went down from around 40 degrees Celsius to about 30 degrees Celsius of the different instruments, sprinkler in plants, in pulses, sprinklers, and sprayers. All of them provide relative similar efficiency. The sprinkler in pulses were a little bit lower in their efficiency, but in general, we had around 10 degrees Celsius lower when we operate the system. When we install some instrument to assess the temperature inside the tree canopy, we found out the effect was a little bit milder. It's around 5 degrees Celsius reduction in the temperature inside the canopy of the tree when you operate the overhead cooling system. I mentioned the issue of water source. So here you can see a picture of the orchard in Gevim, in which we use reclaimed wastewater. And you can see that after 6 days of operating of the system, you can see kind of white color on the branches and some accumulation of crystal on the leaves. So we ask ourselves what is accumulated on the leaves. And you can see here in the right side the level of sodium, chlorine, and calcium when we compare the control to the different treatment. And it was not so much calcium, but it was mainly chlorine and sodium. And chlorine and sodium, it's not something that we would like to accumulate on our leaves, because we know that avocado is very sensitive to salts. Generally, in chlorine, the threshold for damage is around 0.2, 0.25. So we see that with reclaimed wastewater, the left side, we reach this threshold. While in the right side, when you can see the freshwater use, we didn't have problem of salt accumulation on the leaf. But when we use lower quality of water, we see some accumulation of the salt. We ask ourselves then, what from those salt, what is absorbed in the plant? So we took some leaves and analyzed them with as they are, and part of them we washed and analyzed to understand what is absorbed in the leaves. And we can see that a large proportion of the salt absorbed and part of it stay on the leaf. Still, we might have the issue when we are using low quality of water, of damage of chlorine to the leaf when the system is working for relatively long time. Again, remember, this spring that I presented was very extreme situation that the system operated for a very long time, and then we have accumulation of salt. Eventually, we think that the damage was not so severe. The growth of avocado, I don't need to tell you, is very, very intense. And after 2-3 weeks after this cold event, new growth emerged, and we didn't observe any continuous damage. When we look on the water stress of the tree using steam water potential, a parameter using pressure bump, we found out that evaporation cooling treatment improves the water status. It's increased the steam water potential dramatically. You can see in the left side from around minus 8 megapascal, which is trees that face real water stress, to around 4 megapascal. And this is in Gevim, and inside you can see again reduction, very strong reduction in water stress. So we reduce the temperature and we improve dramatically the water status of the trees. So we reduce the stress that the tree is facing. When we look on the productivity of those trees, even though we had this extreme heat wave during spring, the general yield was not so low, but we got significant increase in productivity in both orchards. I know that the yield data here is relatively high, between 20 to 40 ton per hectare, but you need to remember that we work only on trees that had abundant amount of flowering. Those trees were labeled and measured for the experiment, so we multiply the yield of those trees by the number of trees per hectare. So we can see a significant increase in productivity following the operation of this system during the heat wave. After the experiment in Saad and Gevim, we moved to Ruhama, to another plot with replicate, and we reduce the discharge rate of the instrument, the sprayer and the sprinkler, to 15 cubic meter per hectare. The idea was that we have, during heat wave, we have a limitation in the capacity of the irrigation system to deliver a lot of water. The grower generally irrigate, and we need additional water for the cooling. So we'd like to minimize the amount of water we use for cooling. So we went down from the previous amount, around 20 or even 30 cubic meter per hectare, to 15 cubic meter per hectare per hour. And we evaluated whether this is sufficient to give the good result in reducing the heat damage during the heat wave. Again, you can see here using thermal imaging that the area that received the cooling treatment is much cooler, even visually, than the control. And when we look on the average of the temperature, we see a reduction from 33 degrees Celsius to around 27 degrees Celsius. This is again not 10-degree reduction, but this is substantial reduction in temperature. We look for the temperature of the fruitlet on the tree, and we can see in the left side, we can see the fruitlet that were exposed to sun. So we can see a reduction of the temperature from around 38, 40 to around 32 degrees Celsius when we are using the cooling system. And in the shading side of the tree, we see this effect, but the extent was lower. So we see positive impact also on the temperature of the fruitlet. Again, we look for the water stress while using pressure bump, and we can see all along the three experimental here, we can see dramatic improvement in the water status of the tree when we are using the cooling system. This year, in 2024, for the first time, we also evaluated the stomatal conductance. You see that in the control, the stomata is actually closed, while in the sprinkler, the stomata are fully open. The tree is functioning, the tree is doing photosynthesis, and the tree is cooling itself, because when the stomata is opening, then there is additional cooling of water coming from inside the tree and evaporate outside. Another advantage of using the evaporative cooling is allowing the stomata to be open. And again, we see a significant increase in productivity in this orchard following the use of the system. To conclude, the effect of evaporative cooling: reduce leaf and fruit temperature, increase humidity, reduce water stress, increase stomatal opening. We have some issue of salt accumulation on leaf, especially when the quality of water is lower, and reduce abscission of and increase yield. This is our main objective. Regarding system operation, our effective currently sprinkler of 20 cubic meter per hour per hectare can provide sufficient protection against heat wave. And the last experiment even showed that we can go down to 15 cubic meter per hectare per hour per hectare. It will give us also a good result. The threshold for system operation might be temperature above 33 degrees and relative humidity below 30%, and special attention while using low quality water. It was mentioned earlier that system with a relatively higher discharge rate can be used also for frost protection, but this was not the main objective of the study that I show you here. Okay, that's all. Thank you for listening to this presentation and giving me the opportunity to share our result with you.
So really quickly, when Arnon was talking about a 5 degrees Celsius difference, 5 degrees Celsius is roughly 9 degrees Fahrenheit. Okay, so that's going to be a substantial reduction in the temperature of the leaves. So we have time for 1 or 2 questions. So Arnon, did you hear that question? It's being asked, what is how many inches of water?
In millimeters.
In millimeters, how many, what would that be equivalent to for precipitation when you say 15 or 30 cubic meters per hectare per hour?
It's 1.5 millimeter
1.5 millimeters per hour,
Yeah.
which is, there's 24 millimeters per inch. Oh, did you have netting on the trees, or was this out in the open?
Open.
Open. So the question, Arnon, is would you pick a shade structure or the overhead cooling if you had to pick one or the other?
Overhead cooling. The shading is very, very complicated. You need to put it on and take it out, and we have a lot of problem in pollination under net. So overhead cooling is much simpler and cheaper.
So the question is, how about salt and calcium accumulation on the fruit?
We operate the system very, very early in the season when the fruited are like pea at this stage. So even if we have some accumulation when the fruit is growing, we didn't observe any issue. We looked for quality. We assessed the quality of the fruit. We didn't find any impact.
Okay, so we have a question about what is the difference between the pulse and the sprinkler?
The pulses was another type of sprinkler. The idea is that there is kind of container that collect water, and then it's open for a few minutes, and then it stop. Open and stop. So instead of continuous working, it's by pulses. We didn't find any differences regarding the efficiency. The main issue is how much water you apply. The pulses, the size of the drop, we didn't find differences. The main issue is how much water you apply.
Yeah, so the question is, do you think that a fan jet irrigation system for the trees would provide any cooling?
On the ground.
On the ground.
It probably will do something, but the efficiency will be much, much lower if you speak about protection of the canopy.
So the question is, can you just forget the ground application of water and use only the overhead system?
No, I try to emphasize that we have an issue here with the salt accumulation. Okay, so we wouldn't like to operate it when we don't need it, because salt accumulates gradually on the leaves and cause damage. So I wouldn't go all the way to start to irrigate with overhead system. Operate it only to protect against it.
So Arnon is going to be on the, still available when we break for the general discussion. So thank you, Arnon.
Thank you.